Welcome to the RxM Cloud Native Short Takes. I'm Ron Petty, and in this short take of the RxM Image Overview module, we're going to look at what it takes to slim down our images. Here's our game plan. In our case, Docker is already installed. We're going to start from step 2. We're going to create an application, a Docker file, review the size of that file, talk about why it is the way it is. Then we're going to see if we can slim it down, and that's through this notion of multi-stage builds. So we'll see how that is accomplished in a Docker file, reconstruct our image, and hopefully it will be smaller, hopefully significantly smaller. So let's create an application. In this case, we'll do a Go application. Doesn't really matter what the application is. It's really about the dependencies. That's typically what makes images large. So a package main, func main. Here we'll use the built-in print function for those who know Go. Now, if you already had Go installed, you could type in go run hello. This isn't required. This is just showing you that it works. Okay. Next is to create that Docker file. So we're going to do a standard Docker file here. This is probably the easiest way to do it. So to run a Go program, you need Go. Here we're going to use the latest image, latest version of Go. Going to set our working directory. Going to copy our source code that we just created into this image. We're going to build up our module. This is our Go module. This is required by default in Go 1.16. Then set our default command to run this. In this case, we're going to use exec syntax. Now, for those who don't know Go, what this does is when we run our image, we're going to say docker container run and then go app version 1. It's going to trigger go run hello. And what that will do is compile hello.go. So that means there's a compiler somewhere. And then it's going to actually execute that executable that the compiler had created. So let's go ahead and try that. So we're going to build this image. So and what this did was upload our source code and our Docker file to Docker daemon, which read the Docker file and turned downloading this Golang image, created a new image by putting our code in it, and then setting up the default command to run. So now let's actually run it. And there we can see that it actually worked. But how big is it? Let's look at the size of the image. It's pretty large for a Hello World, 862 meg. Of course, that's not our source code. That happens to be the Go standard library and compiler related tools, which we're based on. So this is where multi-stage builds come in. So now, if we refactor this to be a multi-stage build, we can pull out a compiled artifact from stage 1 and make a new image where we already have a pre-built artifact. Now, this is language specific. So this is how you would do it with Go and Docker. So we'll bring up the prior commands. Now, in this case, we'll delete the original content in just a moment. So in a multi-stage build, you make an alias to the build prior to you. So in this case, kind of the original compilation step. So how do you do that? You say as, and then give it a name. In this case, we'll say build env. We still got to put our source code in it, still create a module. But then what changes, now this is Go specific, we need to build a static executable. So for us to do that in Go, we can use the build command, and then we can supply it information via tags argument to not use external dependencies. In this case, the network package. Instead of using the libc version, we're going to use the Go version so we can statically compile it. And then we're going to output it as an executable called hello. So that's stage 1 of our multi-stage build. Next, we want to say from scratch. So we will make a new image that has nothing in it. But the secret sauce is right here. We want to copy from that alias we did earlier something from inside that image. So in this case, we want our executable. And we want to place it, in this case, we'll use the same name in this new image in the root directory. And then we want to set the default command. In this case, we'll use entry point because there is no other options. Let's go up to the top, delete our prior command. Again, step 1, build a static image. Step 2, run it. So now let's try to build the new image. This time we'll call it version 2. Looks similar, but notice that there is reference to this first bit of building called the first stage, ultimately generating an executable, and then copying it over into a new image. So now if we run this new image, version 2, we can see that it works. More important, how big is it? In this case, a lot smaller. Again, version 1, 800 meg, version 2, 1.22 meg. That is the power of multi-stage builds.
Multi-stage image builds is just one of the things you will learn in our container image overview module from RxM. On the rxm.com website, you can build your own custom container course with the courseware builder. Hovering over courses, clicking on a custom course builder, scroll down. Under the module section, you can find containers, click it to open it. Then you will see images overview and drag this into your own outline. That's our cloud native short take, container image overview.